Hello everyone, welcome to this video where we're going to be talking more about entering cost data into STeel and also how we can use that data to optimize for the most cost-efficient section that still meets all of our code and specific requirements of our project. So this is the model that I'm going to be working with. This is a steel warehouse structure, as you can see, a hangar. And on the right hand side we also have some concrete elements which we're not going to really focus on in this particular exercise. Now this model has American cross sections assigned, and we can also set up the design code specifications here just so we can see what's being used. I'm going to use the AISC 360-2022 code, the LRFD version. And with that, I'm going to go ahead and run a code check. So I'll go ahead, run a code check, and I'm going to run this code check for the load combinations in my model. I'll click OK. And I can see here, we're getting some results out of this now. And what we can see at a high level, if I just stop moving the model around, is some utilization ratios. And they range from quite low at the top chords of these curved trusses here, to fairly high with these longer elements like over these beams, the columns as well. So we're getting a range of performance, and this is strictly based on the demand capacity ratios, so looking at strength checks effectively. I can right click on one of these and I can see the code details for that particular section and get a better understanding for why it might be performing the way it is. So we can see here for this particular member, it seems to be governed by slenderness ratio, which isn't a surprise. It's a long continuous column. Now we can also get a performance kind of overview of the entire structure if we go to File and then Print Key Results or Print Code Details, depending on what it is that we want to see. And here we can see that we have the option to toggle on or off data that might be important to us. I'm actually most interested right now in the quantities. So I'm going to check everything else off and just go to Quantities. And it's going to be a fairly simplified report. And we can see here that for this cross-sectional database that we're using, the American cross-sectional database, we have a variety of different steel sections that have been assigned. It's showing us the length, it's showing us the weight. This particular cross-sectional database didn't include surface area data, so that isn't included, but it can be as if your section database has it. And it also, by default, won't come with cost data, but that's what we're going to look at here. So I'm going to exit out of here. Let's jump back into the code input window. And as maybe just a reminder, this code input window that we're using is to validate the assigned sections that we already have on our model. The design input window can allow us to optimize sections for a variety of different criteria. But I want to use this option here to just maybe drill into some of these sections. So if I just look at this column, for example, I can click on this column and I can go to Properties. And I can see here for this column, it's using a W24 by 68 section. I see data related to the dead weight area, the shear area, and so on. And at the very bottom, you also notice that this cost data exists. And this is something that I've actually entered myself. So I've entered a cost, basically a value per ton, and we can enter that ourselves. So I can click OK, and maybe review some of the other cross sections as well. I can right click on this double angle section, Properties, or not double angle, rather, an HSS section, and I can see the cost per ton effectively of that steel section. Now this number will vary depending on where it is around the world, where you're getting your steel from, perhaps even the year that you're doing this. So we don't ship the software with these values already defined, but it's easy to define those yourself. So if I go to the View menu, or sorry, the Edit menu rather, there's a couple different ways that I can enter this data and use that information to calculate the total cost of each element. So here I can see the data that I entered already is under the section cost per unit weight. And this is just showing me here for this American Steel database all the different cross-sectional names. And I can select as many as I like and update the cost per unit weight. And update the cost there. I've got a variety of different costs in this particular model set. We also have a few other inputs that we can define. So I have this member cost factor. And for the member cost factor, I've left this as 0. But naturally, you can see that there may be scenarios where, for example, we might have a cost factor that could affect the performance of the section. Or relative to its peers or its counterparts in how that member is designed. We can also define this in the code input window under cost factors, and I can see a similar input here. And I can just click on the help menu and get a little bit more information about these member cost factors. So rather than cross-sectional cost factors, this is member cost factors. For example, I might have a member cost factor that is higher for a particularly long member that maybe is harder to get to site, so it's going to cost more money, or it's harder to manufacture, or something like that. So we can actually manipulate these cost parameters accordingly. And we have this cost factors help topic here that talks a little bit more about the member cost factors and inputs that we can have. So here I can say the actual calculated cost of each member is going to be the section cost per unit weight, which we've already seen for a number of our different cross sections, times the weight of the member, times the member cost factor, plus a member fixed cost. So again, like if we did have a member that might have required an additional investment to get it manufactured, or maybe shipped to site, or just the construction process is more expensive, we can try to account for that with these different factors. So here I'm just going to enter a member cost factor of 1.0, and you'll notice that any changes I make here will be applied to all selected members, which I have all the members selected in my model right now, so that's what I want to have. Click OK. And now this information will be applied to our design model. And what I can do now is I can go ahead and run a code check with this information. I'm getting my results, and I don't expect any different utilization ratios because I haven't changed anything structurally, just the cost information behind these members. And now I'm going to go to, again, File, Print Key Results, and I'm going to include just my quantities in this report. And my default formatting maybe doesn't work too great for this scenario, but here we can see the total cost of each one of these elements based off of those parameters that I've entered. Now I've pulled those numbers out of a hat. I wouldn't expect you to use the exact same numbers for your applications, but you can see here we have a total cost, in this case here, of 3,940, or I'm mixing up my numbers, 394,591. So I'll say here about 400,000, just to again have a rough idea of what that is. This number again doesn't have to be a realistic number. I'm just using these numbers kind of arbitrary section costs and so on. But now with that in mind, why don't we go to the design input window, and we can select our members that we want to design for. In fact, maybe I'll just review some of the design groups, so I can look at my column design groups, for example, and the members that are part of that design group. And I can see that it's looking right now at using a W24 section, but maybe I want to go with something a little bit larger, a little bit smaller perhaps as well. I'll give it a name. I'll just call it columns. And I'm going to say, just give me the one that has the lowest cost. So it's going to look at all the available sections in the steel table that I've assigned, and it can sort based off of which one meets all of my criteria but has the lowest cost. Click OK. I'm going to select as well maybe the top chords of my trusses here, and all the other members that share that same cross section. And I want to sort it in a similar way. I'll just say here, I won't give it a name, but we'll go cost, and maybe I can consider some different size sections once again. I'm not going to spend too much time fine-tuning this, but last and not least, let me select some of my bracing. And all the members that are part of that design group here, you can see this using an HSS section, like we had mentioned earlier. I'm going to sort by cost, and we'll just use a square section once again. So now that I've got this all selected and all input the way I like it, let me go ahead and select the entire structure. And we're going to run a design for all 5 of my load combinations. So finding a new cross section that works based off of the design groups that I currently have set up. So I'll click OK. And now we're getting new results out of this. There's quite a bit going on here, so maybe I can just simplify my view a little bit more, display my design results a little bit differently. So I'm not going to show the proposed section or the missable lists icon. I just want to look at basically color coding and utilization ratios. And we can see they're all passing now. But if I go to the File menu and I go to print key results now, just looking again strictly at the quantities, I can see here the cost that's calculated has actually gone down. So it was originally about 400,000, now it's around 272,000. So we've been able to optimize the section choice based off of whatever section will pass all of the criteria for code requirements and maybe any other custom requirements I might have had for my example, or my design group rather. And it will also make sure that whichever one is adequate, it's going to select the lowest cost version of each one of those. So here we can see we're getting perhaps a more efficiently designed structure. Some of our elements, like our top chords, for example, might be using lighter sections when they didn't require such a heavy section or having low utilizations. This is all based off of our design group data as well, which is something we talk about more in our steel design training course, available on demand on our website. And if you'd like more information on that, you're certainly welcome to check that out.